Here we're going to look at question 42 of the ENGAA 2018 paper. So in this question we're told we have a ball of mass 0.2 kilograms which is thrown vertically downwards at 4 meters per second from a height of 0.45 meters. We're then told that this ball rebounds off the ground at a speed of 2 meters per second. The question asks, how much energy is lost in the collision? If you would like to have a go at this question, go ahead and pause now. Otherwise, let's have a go at it. So, if we want to find out how much energy is lost, then we need to find the change in energy. So we need to find out how much energy we have before the collision, before the bounce, and how much we have after the bounce. So let's start by finding our initial energy. Now to do this, we could find the energy of the ball right before it hits the bounce, or we could find it right at the moment that it's dropped. They should both be the same because no energy should be lost on the fall down, since there's no mention of air resistance at all. So no work will be done by the air resistance, and the energy is just going to be the same. So how would we find this initial energy, which I've labelled here as being E1? Well, it's going to be a combination of the kinetic energy of our ball plus the potential energy of our ball. So how do we find the kinetic energy? That's just given by a half multiplied by the mass of our ball multiplied by its velocity squared. Then the potential energy, well, this is just going to be the gravitational potential energy, which is given by mgh, where g is just the acceleration due to gravity and h is the height the ball is at. So let's go ahead and substitute in our values we've been given. So our kinetic energy is just going to be a half multiplied by our mass, 0.2 kilograms, multiplied by the initial velocity, 4 meters per second squared. Then our potential energy is going to be our mass, 0.2, multiplied by the acceleration due to gravity, 10, multiplied by the height the ball is at when it's dropped, which is 0.45 meters. So doing some arithmetic, we find out that this is going to be equal to 1.6 as our kinetic energy and 0.9 as our potential energy. So our initial energy in total is going to be 2.5 joules. Well, now that we've got our initial energy, we can go ahead and try and find our final energy. So what's this going to be just after the ball is rebounded? Well, it should just be the kinetic energy of our ball. So this is just a half multiplied by its mass, 0.2 kilograms, multiplied by its velocity of 2 meters per second squared. Doing some arithmetic, then we find that this is just 0.1 multiplied by 4, or 0.4 joules. So, with our final energy and our initial energy, we can find the change in our energy. It's just going to be our final energy, take away our initial energy. So that'll be 0.4 minus our 2.5, giving us an energy change of minus 2.1 joules. So 2.1 joules have been lost, and this is going to correspond with answer G given in the question.